Typhoons in Hong Kong have always posed a serious risk, with accompanying high tides and elevated flood potential. The problem is that the ordinary Hong Kong citizen does not have enough information on how to protect themselves from this risk. As of now, the Hong Kong Weather Observatory provides information on the typhoon, but hardly on the subsequent effect on the sea and tides. Our web application and physical model work together to combat this problem. Our aim is to provide a low-cost and accessible means of checking the tide level when a typhoon signal is hoisted, allowing citizens to take necessary precautions.
As you can see, our web application includes a map where users can click and choose on the locations of different physical stations to see the tide situation there. Upon clicking the link of a physical station, users will be led to another page where they will be able to view the real-time tide height data and see real-time updated images of how the tide looks like. Integrating the Google Firebase services, we were able to construct a database and host our web application. Our web application is created using Firebase tools alongside HTML, JavaScript, and CSS. The leaflet JavaScript library was used for a map function, and the components in our physicals model include an ultrasonic sensor, which measures distance using ultrasonic waves, an ESP32 camera, which is essentially an independent camera with self-hosting abilities, and the ESP32, which connects to Wi-Fi and writes sensor data to the database so that we can show data on the web app.
To ensure the accuracy of our app, we have designed a physical model that simulates the rise of tides by adding water. As the water level increases in our physical model, the tide height displayed on the web application will also rise accordingly. If the tide height exceeds a predetermined limit set in our system, a warning will be displayed on the website, notifying users of potentially dangerous conditions. When creating the model, we ensured to calibrate our measurements by comparing the sensor readings against reference points in order to validate the accuracy of our measurements. Furthermore, the ultrasonic sensor used in our physical model is capable of measuring the water level with a high degree of precision, providing data with up to 3 significant figures, which allows us to capture even subtle changes in tide height.
We collected data from 29 participants between the ages of 10 to 60 to assess the needs and wants of information on Hong Kong's weather patterns. As shown by the graphs below, 65.5% of our target audience are concerned about Hong Kong's unpredictable weather patterns, 51.7% would use an application to check water levels, and 96.6% of users would appreciate the ability to receive warnings for impending floods. Furthermore, real-time surveillance feeds and the ability to check tide levels in different areas are popular among 75% of our target audience. Ultrasonic sensors, maps, and a network of ESP32 cameras, our systems are able to provide a wide range of real-time information to ensure the safety of all Hong Kong citizens. The survey displayed a high number of people interested in surveillance feed from Sha Tin, Zhangguanou, Jiuqingling, Whampoa, Lantau Island, and Sham Shui Po, and so we will be expanding our database to include cameras in these areas. Overall, our app provides a very promising solution to a very real problem. We will continue improving and working on this project, but we are proud of what we have accomplished so far as a team of students. Thank you.